Welcome to the 10th class in data analytics, where we explore interactive visualization, probabilistic modeling, and machine learning with Mathematica. And so we are kind of like the latter half of the class. So we focus primarily on the machine learning, right? And as explained in earlier class, machine learning, it was motivated originally from the need to program AI, basically, right? You can't program AI with a bunch of if then. So you have to program AI with an algorithm that somehow learns to mimic input, output, or behavior that we wanted to learn. And there are two kinds of learning that's relevant to our data analytics class. There are actually three principal machine learning paradigm, right? Supervised learning, unsupervised learning, and reinforcement learning. But for our class, the supervised and unsupervised learning will be very much the main focus for data analytics, okay? And why is that? We have a continuous thread from the very beginning, from class 1, if you might recall, where I would have or should have said data analytics, for the most part, is about asking two kind of questions. Where are the data? Where are the values? Where's your population? Where's it centered at? Where's it scattered about? Okay. And the other question is, if I knew one aspect, i.e. X, i.e. independent variable, i.e. input variable, can I better predict Y or something else, some aspect, right? So dependent variable, output variable, response, so forth, okay? And so where the data in interactive visualization, we look at it, we use what? We use all kind of data plot, right? Scatter plot, all kind of stuff, right? Or histogram. And when we want to talk about if I knew X, do I know Y? Well, that's where you have this kind of X, Y, or scatter plot. So again, me start again. For the where are the data, you would look at histogram, and can you tell Y if you knew X? You know, the sort of relationship between X to Y. That's when you use the scatter plot. Then we move to probabilistic modeling, where that question about where is the data, that has to do with the distribution plot, right? So what you do, you try to find the distribution, and we talk about normal distribution, gamma distribution, all kind of distribution. And in the midterm, you already had some question about using the function find distribution, right? Whereas if you're talking about if I knew Y, do I know X, then that's where you have the regression equation or regression analysis, right? Well, in machine learning, the question about where are the data, that's mostly answered by what would be in chapter 5 of this book, which is unsupervised learning. Whereas if you ask a question like, if I knew X, can I predict Y, right? That would be answered in mostly in chapter 6 of this book, which is supervised learning. Okay, so today we're going to finish up supervised learning and maybe give you a sort of like a head start on unsupervised learning, and then we'll continue with unsupervised learning in the next class, right? So now I did mention that we flip the order presentation, where I start with oops, what's happening? What did I do here? Sorry. I think I accidentally erased everything. No, did I? Okay. Document. Work. And lectioner class. And this one, I'm using the same one that I used with you. Okay, let's try again. Okay, so once again, this is the header file that's kind of for formatting purpose. Okay, supervised learning, right? One of the reasons I started with supervised learning is because there's a callback to regression analysis. Okay. So anyway, this is we kind of like did this this kind of like callback already of what it would be like to think of regression analysis as a supervised learning problem, right? So, but basically, the only thing that we show a whole bunch of this, and the only thing that I want you to basically memorize or have it imprinted in your brain is that with regression analysis, if you want to fit the data, a relationship between X and Y, you have to have an idea of what the functional form is, right? In this example, I kind of gave an example of, well, let's have a affine function, which is essentially a linear function. I have a parabolic fit. I have a cubic fit. So these are sort of things you have to have in mind, because otherwise, you wouldn't know which function to use, right? You wouldn't know which function to use. And then, okay, then we talk about the two class of supervised learning problem, okay? And they are distinguished by what? The number scale of the output, right? If the output is something that is that correspond to a nominal scale or ordinal scale, basically just some kind of identification tag, right? What kind of problem do we call that? Come on, you should be very quick by now. Classification problem, right? Okay. Again, what you do in data science or in data analytics, that's called classification. Biologists, friends would call that identification. Okay. Because classification is to create a taxonomy. In our case, the taxonomy, the label of this is an elephant, this is a chicken, this is a fox, this is a cow, this is already established. Okay, so when we say classification, we mean we identify a particular animal and say, this is a cow, right? Okay, so that's called classification. Whereas if the target, right, the right response we want, the Y, is interval or ratio scale, basically numerical values, right? We would call it prediction problem. Okay. Now, this term sometimes gets thrown about and mixed about, but for our purpose, let's do that. Let's just keep it clear between classification problem, and prediction problem. Why? Because when we build the model that does the classification, we will call it classifier, right? And the model that does the prediction, we will call it the predictor. Okay. Now, let me give a little bit of an outline. Maybe this is a side note. Sometime I would go to the note, but we can do this here. Okay. Okay. Now, this one is not in the book, but this is kind of like the way I thought I best explain how you approach your role. Okay, well, let me what I mean by that. Classification problem. Okay, classification problem, right? Now, what is the task? Okay, task. What's your task? The task is given X, right? Given X, right? You should input X, output Y is equal to some kind of label of X. Okay, so that's the main task, right? Okay, that's the main task. Now, let me kind of like give you what your role in it. Okay, if your role is a pure user, you are pure user. Okay, you're a pure user. Okay. What are you given and what do you have to do? Well, you're given this. You give a classifier. Okay. You're given a classifier. Okay. And then your task is to basically do this. And then X, right? That's basically your job, right? And you're done, right? Okay, your job is done. Okay, now today, you're more than pure user. If you're a data scientist, okay, if you're a data scientist, you're not given a classifier. You're given actually bunch of pair of x, y, right? Let's use x arrow y. Okay, you give bunch of this. Then your job is to build model, classifier, okay, right? And then you test. Oh, you build this based on this. Is this test, training and testing data, training and test set. Okay, build the model on training set, and then test the model let's put it my classifier, right, on, let's put it here, on test set, right? And then you deliver to client who is the ultimate user. Okay, so those are the two rules. Okay, I just want to make sure that because sometime if you read my book, because I'm giving the whole story, right? You might get the impression that every time you use classifier in life, you have to start from training. Okay, maybe that's the explanation that maybe I should have sort of like make a big warning that this is not for everyone. Okay, so imagine that you are not really interested in being a data scientist. Okay, you happen to have a picture of a flower. You want to know what it is. You would not build a model that classifies the flower. Okay, you would say, okay, can somebody give me the function that classifies flowers? I would use it. Okay, now here's the thing, you guys are kind of in between. A lot of you are not data scientists, but a lot of you will be working with, let's say, a sustainability problem, right? Working with smart city problem. You don't want to be data scientists, but too bad, you have a data set that's specific to your problem. You can't rely on somebody else having built the model for you, right? So you have to be, you have no choice. You have to build the model yourself, right? Now, let me emphasize that when you work with Mathematica, this is how you start working with it. Okay, you load your data, you call this function, like I said, it's one-liner, classify, and it's going to build a classifier. However, are you an expert data scientist yet? No. So even though in the book, it carries through all the way to the testing, right? If it's a real life problem, problem that's worth a zillion baht, or problem that has meaningful impact to people's lives, are you going to use automatic built-in function like that? No, you are actually going to try to do sort of like a model development, right? Okay, so please, this is a caveat that perhaps I should have put in the book. Okay, so you're kind of like in the middle stream. You're kind of like learning what it's like to build the model from data set, right? And then test it, and then you can use it. But in reality, there is an easier way. Basically, if somebody already built a model for you, and there's also a more complicated way, which is even though you build a simple model like this, certainly you're going to do a lot more testing, a lot more validation, right? So it's going to be, so this kind of like, what's in the book is kind of like intermediate step. You're not quite expert in data science, okay? But you're also not quite like a pure user who doesn't actually touch the data. Does that make sense? Does that make sense? Okay, good. Now, with that in mind, okay, I want to show you this level first, okay? Then I'll go to the book and I use this level, okay? So what do I mean by this? This level is given a classifier, okay? So now what I want you to do is open up a blank sheet. Okay, don't worry, we'll get to this, okay? Actually, we did this last week, right? We actually get to here, the procedure, the full procedure. So this section 3 here, this procedure, partition the data set, train, test, partition, train, test. This is basically here, okay? You build the model on the training set, test the data set. So this is kind of a novice. Let's put this. Data scientist, okay? So use classify function in Mathematica to blah, blah, blah. And then use what's it, classifier performance test, classifier performance. I don't remember. Hold on, let me look. Yeah, there it is. Predict the classifier measurement. Predict the classifier measurements. Classifier measurement. Okay. Function to dot, dot, dot. Okay, so that's the idea. Okay, and same thing with prediction. Okay, now I want you to step back and say, okay, I'm gonna be like very naive now. I'm just gonna be a pure user. Okay, so in this case, you're thinking of a program as if it were a calculator, right? Instead of saying I put in 3 and I put in plus and I put to 2 and I expect a 5. In this case, I put in a picture and the output should be, what's the name of that flower, right? Now, of course, with calculator, you have a built-in plus, minus, multiply, subtract, divide, okay? Likewise, with classifier, you have built-in classifier, right? So now go to, let's start a blank page, completely blank in Mathematica, okay? Okay. Now, type classify. You will notice that it immediately is a function, right? Right. And then you go to a help page, go to F1. Basically, this is a help page, right? So classify. Now, I want you to walk this with me. Now, again, right now, for the first half an hour of this class, you're actually going to be a pure user. Okay, step back everything. Step back. Okay, forget about the book. Okay, the book takes you to the next step. So I want to step back a little bit. You're just a classifier. You're just using something. Okay, you're just using it. So now, okay, this function is a little bit interesting. Now, this is any of you from a very rigid programming background is going to be shocked, but this is like operator overloading in a very advanced way. Okay, the word classify here, okay, have you opened this page? Right? Okay, now. Right? Good. This, and this are doing almost very different things. Okay. What I mean, or what I use in class and in the previous class as well as in the book is here. Okay. So classify, right? And I put it data in the form of XY pair. Okay. Classify, I put the data. Okay. I supply it with data. When I supplied with data, it's basically previous example of XY pair. So that's what I mean by you building the model. Okay. So this is to give it a full explanation. This here asks you to put in your data. Okay. So again, this is kind of intermediate Basai style of project working. You're working with sustainability problems, smart city problems. You have your own data. You want to build a classifier. You give it the classifier. Okay. That's what this first button, this first line means. Okay. And what you get, you would do this. You would say something like my classifier equal to classify, and then you put in my data. Okay. I haven't got my data yet. Okay. So, but in the first half an hour, I want you to focus on something else, which is kind of like, it's kind of hidden a little bit, to be fair. It's hidden a little bit. Okay. So you click down to this. You click down to this detailed option. Okay. Now, obviously, this is not used that often, but you know, this is what I want to show you. Go down here. Okay. Instead of putting in the data, okay, you can put in this, what's called built-in classifier function. Okay. This is where you go back to baby step. You say, if there is a built-in function, like a calculator, plus minus, right? You can use it without doing any work at all. Okay. So let me say that again. If you're working on a smart city problem, okay, and you have a problem that you want to sort of like people come from different countries, okay, and you want to classify people according to their flag picture or something like that. You have to build a picture. You have to build a model that say this flag is Malaysia, this flag is Singapore, or something like that, right? Now imagine in some case this problem is so ubiquitous, they might as well build a flag recognizer in it for you. Okay, this is kind of built-in function. This is what I mean by, in this case, you're not going to do any work. You're literally going to be a pure user. Okay, now that is not very powerful way of using Mathematica, so it's not that emphasized. In fact, I didn't talk about it at all in my book. Okay, but there are things like that built in. For example, okay, and you can go through this. So instead of putting in the data, what you put in is the name of the pre-built classifier you want to use. Does that make sense? Okay. Now, yeah, let's do that. Okay. I'm not going to enter any of this because I haven't got data. This one here, right? When you use it, you have to what? You have to do what? You have to build this first. Okay, you have to build this first. This is my data. Okay, this is my data, right? I put in my data, I train it, and then I say my classifier, and then put in unseen or new item. Okay, and if you did this and you've done your job right, okay, you are going to get as an output, what are you going to get? The label of the new item. Right? So maybe it come up something like a orange or something. Okay, whatever, I don't care. Okay, so that's the job. Okay. However, so what was the example I just used just now? Flag, right? Okay, so let's say I put in some kind of flag, and it's going to say something like Thailand. It's going to give out Thailand. Okay. Now, what I'm talking about in the first half an hour of today is to use a built-in one. So let's go classifier. I'm going to call it, I think there's a country flag. Now, what you do is just type in quotation and it's going to, yeah, there is. So these are basically, if you see country flag, Facebook topic, facial expression, all this, it's exactly the same thing here, right? Okay. So actually you don't have to go to this page, but it's spelled out nicely. So it's already autocomplete. So let's say I'm going to do country flag, right? Country flag. Okay. Right. And then once I call this, I give it the flag. So let me give let's go to example. Let's say, okay, hold on. Let me say, let's get give me a country, entity, country. What country you want? Indonesia? Let's go Indonesia. Okay. So that's Indonesia, right? And let's give it a flag. Say it's gonna look up. The first time it's gonna wow. Okay. So there it is. So that's my Indonesia flag, right? Am I correct? Is this correct? Okay. So if I did this, see that? That's a terrible. Why is that? This Monaco looks the same thing as Malaysia. Is it? Ah, okay, okay. So you've been out popular by Monaco. I'm sorry about that. Boy, that's not good. Okay, let's go Thailand. I think Thailand is okay. So Thailand flag. That's embarrassing. I'm sorry about that. Should have checked. Okay, let's put in Thailand flag. Okay. Right. So this here, okay. This here, to do this, what do you have to do? You have to call this function. Oops, sorry. Given, I'm gonna modify this statement. Given built-in classifiers, whole bunch of them. The task is y is equal to classify, and then what do? You put in the type, right? So for example, a name of built-in classifier. Comment. Okay. So for example, okay. So for example, this. Okay. This is your classify, right? You should have like a, well, I don't know. I'm kind of expecting you should have like a very startle look, because for people who are from programming background, the thing they're taught is that a function, takes in a specific input type and does certain thing. This thing here, I'm not giving it the data. I'm actually giving the name of a built-in, and it knows how to resolve that. It knows how to tell what's on your mind, basically. Okay. So I'm not giving a data, but I'm using the same function. So if I actually give a data set, classify, let's give a data set. Let's say, okay. Okay, let's do this. Let's say you have 90. Okay, if you get 90 on your midterm, you should get an A. If you get 80 in a midterm, 80 midterm, you should get a B, right? And if you get 70 in the midterm, you should get a C. Okay, now this is not, I gave an example of class grade as example for clustering, but in this case, I have in mind, I said 90 is an A, 80 is a B, 70 is a C, and anything, say like something like 60. Okay, I'll just make it 3 grades, okay? Now, what do you think would happen when I press enter? It's not going to classify anything, but it's going to build a classifier. See, it builds a classifier function. Now, if I want to use this classifier function, right? And you click it, okay? So I'll go slowly, sorry, because today, if I go quickly, remind me to go slowly because I want you to go every single keyword I type, okay? I don't want you to listen only, just type everything I say, okay? So if you click down, it's gonna say, it is numerical. That's your input. Your output is ABC. So there's only 3 class possible. And logistic regression, that's what it uses. And number of training examples is only 3. Right? Now, if you want to use this function, okay, to give a grade to another student, okay, you have to say, okay, my grade assignment equal to classifier. So I name it that. Okay. So now it becomes a function. So now I grade a student. My grade assignment. Oops, I have an E. Okay. My grade assignment of a student. Now, obviously, if I put in 90, I'm going to get what? A. Okay. Now, the thing is, what if my students didn't get 90, 80, or 70? What do you think will happen? Well, let's see, get higher than 90. What do you think should happen? 95. This guy gets an A, right? So it understands that, yeah, if you have this is A, B, C, higher than this, well, obviously it should be A, right? Now, on the opposite side, let's do that. Let's give some guy who only got 60. Now, in my mind, that should be an F, but you know, in this case, it's a C because I only give it 3 grades. Correct? Now, I'll give you a little bit of a shorthand. What if you want to build a classifier and you want to use it right away? Then you can do this. Okay? Right? See that? So, okay, 91. Now, notice it takes a little bit of time to calculate. Okay, watch my hand. I'm going to give you the same number. Let's give it 72, and I'm going to give it 72. Okay. In fact, okay. In fact, I'm going to do this. Timing. I put timing around it. I put timing around it. Okay. So what it's going to do is it's going to give me the time it takes. Okay, ready? 0 second. Why 0 second? Because it's already trained, right? Okay. Now this one is going to take a bit longer than 0 second. 0.685. Because every time I enter this function, what happened? I build this function and then I use it. Okay. So in other words, this thing here is the same thing as module my classifier equal to classify. Then once I build it, I use it to classify 72. Okay. In fact, let's do timing again. See, 6, 7. Okay. Right. So in here, imagine that you just bought a calculator called Mathematica. You're not programming. You're not doing anything. You just want to use it. And you know that there's a thing called classifier, right? So you go to this page, maybe help page, and you see, okay, how do I use it? Ah, okay. This is how I use it. Okay. Oops, sorry. Where's the help page? Where do you do my help page? Okay, there's the help page. Okay. So you can see that, okay, here, build a classifier, use the word generate, but I use the word build. Build a classifier function based on the data. Okay. Now, if you want to use it once, you put the data and you put the X. That's what we did just now, right? Now, this thing is not useful because it's very rare that you would have a whole data set, let it train and use it once. Okay, so this is really silly. This thing is kind of silly. This kind of pipeline is silly. Okay, you take a long time to build this classifier, and you're just going to use it once. Okay, but that's what it is. That's what this is. That's what this means, and that's what this means. Same thing. Okay, same thing exactly. Okay. However, the way you would use it most of the time is build a classifier. The way you would use it is build a classifier, and then now this is the one that takes a long time, right? And then you use it to classify 72, and this is going to take 0 time. Okay, see, 0 time, 0.01. Okay, right? Okay. So this is exactly what you saw in the second line here. Okay. Now, property, this is where you get to do something else. Okay, you get to use something else. Give it something else, like probability. Okay, for example, let's go back to that Thailand and country. Okay, so this is output is Thailand, right? Now I don't want to know Thailand only. I want to know property or probability. Let's say probability. See, actually what it does, it gives all the probabilities. And this one is gonna be very powerful, right? It happens that this model classify all the world already. Okay. Now, if I were to do this from scratch, it would take forever. Imagine, right? But this is already built in. You buy Mathematica, it's already pre-trained. It's like ChatGPT, it's pre-trained. So all you need to do is do this. Now it does. This is what's cool. Look, classify and gives the probability. What it does, it actually gives you, before it gives you Thailand, it gives you the probability. So the probability that this flag is Afghanistan is very low. It's only when you go to Thailand, where's Thailand, that this probability is high. Okay? Does that make sense? So if you ask for the prediction, yeah, it's going to choose the highest one. But if you want to know how likely is this going to be identified as something else, so, remember that quote unquote mistake we had about Indonesia and Monaco? Let's go back to it. Let's see why is it that we made that mistake. Let's go back. Okay. Let's go to where is it? Country flag. So let's see. Entity, country, oops. Country, Indonesia, and flag. Oops, sorry. Get the entity first, right? Now watch this, okay? Okay. For reference, let's go to Monaco. What's the probability this is Monaco? Where's Monaco? Monaco 0.0003. Okay. Also, go to Indonesia, 0.003. Okay. Absolutely zero. So let's do this. Okay. We knew that it got it wrong, right? So this should be Indonesia. Where's Indonesia? Okay. Oops. Okay. The reason it got this wrong is because when you go to Monaco, where's Monaco? HIJKLMNOP. Huh? It's got that 9. Okay. Even though it's not the correct. So basically, yeah, that's how error comes about. Now, this is also presumably has a very similar probability that it is in the, let's see. Okay. Yeah, I have to go look. Okay. Right. So this is the first thing I wanted to do today, which is simply this. Now, obviously, this is this country example. Okay. So this is sorry. I don't want to erase all the example. Okay, let's do this. Classify, okay, and then country flag. Now, obviously, I got Thailand. Fine, I'm happy, right? What if I want to do something else? And they classify. Now, this one, let's do internet search. Okay. Picture of, give me a famous person. Alan Turing. Okay. Copy. Now, if I did this country flag and I put in Alan Turing, it's going to be silly. Okay. I don't know how I came up with Cyprus. Okay. It's with, you ask it to give something, it's give something, but it's going to be wrong. Okay. However, if you give it to something like, I think person, maybe. Is there one person? No. Famous person? Okay. There should be something like classify and celebrity, maybe. There should be one. Anyway, I can't find. Okay, let's try facial gender. Male, okay? Something like this, right? Or let's try something else. So obviously, depending on what you want, you have to get the right, otherwise it's gonna make no sense. Okay, so let's try something else. Classify, what's the one that you use a lot? Facebook topic, maybe? Okay, man, sentiment. Okay, so sentiment, let's say you have a page for review product. The movie was so I didn't mind. Okay. Negative. Okay. The movie rank was one of my favorite. Why this one's a bit silly. It's my favorite. Why is it negative? Anybody? Kind of weird. Oh, okay. I have to enter. Yeah, it's 95. 95 was my favorite, my all time. Is it favorite? Maybe I had a U in it or something. Okay, something like that, right? So this is kind of built in. Now, is this something I want you to rely on? No, absolutely not. Okay, absolutely not. Okay, so that's just half an hour. Okay, so this is how you would use it as a pure user. Okay, so this is just to get you going and say, okay, yes. Is it powerful? No. Is it accurate? Probably not. Okay. Having said that, okay, you guys know this. Every time I put a new type, like a country classifier or sentiment classifier, it's going to load something. It took a while, right? So what happened is that anytime you have this kind of built-in, when you launch the program, it doesn't load. Okay, it's like in Python, if you don't include, it doesn't come up. Okay, but the first time you type it, it's going to load. So it's going to take a while. Now, let's say you're not satisfied with the sentiment classifier. Okay. Okay, I'm going to put pure power user. That's another word. Okay. So now, instead of given built-in, you given model repository. Okay, then you would use that same as above. What's the difference? This is kind of like a toy example. This is the thing that I showed you just now. Okay, now if you're going to be again a power user, you want to use this in a real problem in your application, but you don't want to train. Okay, let me say in parenthetically, why would you want to train? Why would you not want to train? Okay, if your problem is the same thing as the whole world, like identifying cats from dog, do you need to train? Would you retrain a model for that? No, right? Right? If you actually create new kind of animals, okay, it's a new animal that you name yourself. It's like you're drawing an imaginary animal. Would it make sense for you to use a built-in model that identify animals? No, you have to retrain. You train the whole thing yourself, right? Most of the situation is actually in between. You would probably want to recognize animals, but in your problem, maybe you're not trying to identify cats from dogs. Maybe you try to identify stray cat from healthy cat. In which case, what you would do is use a model that somebody else already built and then modify that. Okay, I'll talk about that later. But let's go to my point, which is you can actually be pure user. In other words, you don't want to train anything else. You just want to use a result, but you don't want to use this Mickey Mouse thing. You want to use a real model. How would you use a real model that's built by advanced academic research university? Well, in Mathematica, you would go to, let me search. I don't know what the name keyword for it. Mathematica model repository or something. I think it's something like that. There, no, that's data repository. Not data repository. Neural network repository. There it is. Okay, there. Okay. So this here, see that? It's not, okay, just now I said something like a classified country flag. Now imagine that country flag is such an important problem that all the universities in the world are trying to identify country flags. Imagine that, right? Then you would look under the section called classify country. There'll be a whole bunch of things like classify country flag by this university, by that university, by OpenAI, by this, by that. Well, this is what we're talking about. All this are advanced models that have been loaded into an ecosystem. Okay, so all you need to do, for example, one of the things you hear a lot is inception model. That's very advanced. Okay, that's this guy. Now, I'm not going to demonstrate it to you because when you load this, it's going to take minutes, not seconds. Okay. Now, you guys remember this? When I built this thing, look at how simple this is. This is the model description, right? This classifier is a numerical thing, tree class, logistic regression, simple, right? This is the whole model description. Now, look at this one. This is a model description of this thing called Inception V1. So if you are a power user, you would basically go to, okay, you go to that page, go to that page and then take what you like. Okay, and then the way you would use it, like this, see? Instead of classify, because it's a neural network model, the keyword now is network model, like that. So exactly this, okay? So you don't have to build a new model to classify Peacock because Peacock classification is not something you do in microsecond. It's something that takes maybe an hour, very advanced computer of your kind, maybe with GPU, maybe seconds, but still take a long time. Now, let me copy this and put it here just to show you how you would work it. But of course, oops, sorry. Yeah. The problem is there. Okay, so I'm going to do this. Okay, I'm going to do this. But notice what happened when I enter it. Now, if I did this one and I put another picture, it will be very quick. But this is the first time I am calling this net model. It's going to go to a load a while. It's going to take minutes just to load. Five seconds. Okay, not too bad, not too bad. It's not minutes, it's seconds. It is a peacock. Okay, so let's try another animals. Picture of wolf. Now, this time it's going to be a little bit quicker because it already loads once. Gray wolf. Gray wolf. Okay. Let's see if it knows Alan Turing. Let's see if it knows Alan Turing. Alan Turing. Whoa, that's not very good. Okay, it's not good at a specific person. Maybe a country flag, maybe it would know it's a flag. Again, this is very specific. Image or file object. And this is an image file object, why not? Okay, that doesn't work. Okay, so there it is. So if you are a user, you use in this simple thing that, you know, automatically comes up. If not, you go to this page. Now, let me give a heads up a little bit. Some of you are going to data applied digital intelligence concentration, in which case you would actually work in an even larger universe. Okay, so imagine this. Okay, watch this. Where's that page at Mathematica? This page here, this there. Okay, this page here is Inception, right? Inception is new, but it's like 5 years old. Okay, all the model you see here listed are at least 3 years old, I would imagine, 2 years old. Okay, so it has to be out there. Now, what if you want something more advanced? And this is where if you go way beyond data analytics, you're going to be data scientists and machine learner. Okay, you will not just restrict yourself to this. You would actually go to this page called, and this is what I do professionally, papers with code. Now, unfortunately, this is much harder to do, but the universe is much bigger. In other words, something that came out in 2004, 2024. Oops, why do I have this paper? Weird. Okay, a paper that came out yesterday, October 8th. Okay, it's already here. Unfortunately, to use it, it's very difficult. You have to go to GitHub code page, load Python, PyTorch, build in the library that has this kind of like what's called a dependency. Python is a language, but to use this thing, nobody writes a whole library. This library depends on that library, depends on this library, depends on this library. So to use this, you have to go find out, hey, to use this, what do you need? Download them all, okay? And this is called the GitHub page, okay? This is what professional people do, okay? You guys would be dead if you had to do this for your project, okay? But if you can, it's good because this is the way people work nowadays, okay? People work nowadays. So this thing is cool because again, you have something that was published 2 days ago, right? Was it? Yeah. Where is it? 8th of October. Okay. So by the time you wait for Mathematica to put it in their ecosystem so you can use it easily in 1 line or 2 lines, you have to probably wait 2 years or something like that. Okay, when they get around to it too. Maybe the next version. I'm not sure how long they do this update. So you can use all this very easily. Where was it? Yeah. So age estimation. Oh, that's another one. See, this is very good. So, okay. Yep. So copy this and yeah. Where was the example? Okay. Okay. Now again, this thing is gonna take a while. to run because the first time it's going to run, it's going to load this thing. 10 minutes. I'm not going to wait. Okay. Anyway, I wanted to try to see if they can guess the age of Alan Turing. 3 minutes. Okay. 2 minutes. Oh, 3 minutes. Okay. Maybe you'll come back. Okay. So you see how easy it is to use in your problem. If you're working with your problem and the machine learning model that you require is not so cutting edge. Okay. Let's say model that, let's give it a hard cut-off date, 2021. Okay, let's say. Okay, if your model, the model that you require is not going to require anything more advanced than 2021, chances are you'll find it here. You find it in this page. Okay, anything up to October 2024, probably not. Right? Okay, so it's up to you. All this. Now, for your project, if your project is object recognition, right? Definitely, I don't want you to turn in something like this. I want you to turn in something like this. Okay? So this is basically the model repository, LNS, all this stuff. This is all in there. Okay. In fact, I will use one. I was going to say one or two, but I think just one of them in the exam. Okay. So that during the exam, you have to enter, and this is going to have you wait for 3 minutes or something, but that's not too bad. Okay. So let's say the exam asks you to do this, you're going to have to wait 3 minutes. So, okay, fine. So this is you as a power user. Take what you need. Now, as a novice data scientist, you do this. As a professional data scientist, may have to go to Power Paper with code.com to get models, model built, invented in the past few months. You may not. Okay. In my project, I never had to use anything that was invented 2 months ago. So in theory, I could have done most of my project kind of like in here, you know, model that are 5 years old, 4 years old. This is okay. Now, do you guys remember regression analysis, right? You learn regression analysis. How old is regression equation? 300 years. Okay. So if you're going to have to build your model based on something that is 2 years old, it's not so bad. Okay. It's not so bad, right? But it also depends on what your problem is. So your problem is visual recognition. Yeah, you can find it here. If your problem is like a language model, which is something that, you know, very active right now, 2023, 2024, you will not find it here. Okay. So you will not find any kind of large language model. You have a little bit here. I think there's a bird here somewhere. Yeah, there is. There's a vision okay, that's a vision transformer. Let me find the word bird, B-E-R-T. Yeah, there it is, bird. So bird is a language model. So yeah, so you do have some built-in language model in here. Okay, it's not as advanced as GPT, obviously, and in fact, GPT is not available for you to download. You don't have that enough compute to do it locally. Okay, so that's how you would do it. Okay, now let's go to let's take a quick break. We'll come back and do this, and this is where we take step by step from the textbook. Okay, can we do? Yeah. Okay. Now, this is called, by the way, this is the style of working in Mathematica ecosystem, something that is large, but not professionally large, something that's not proprietary, something that's publicly available. You can find it in here. So this is for the model. You also have what's called data repository, okay? Now, just as this is not what I want you to base your final project on, I want you to use something like this. Also, I don't want your final project to be based on example data, right? Example data is literally just that, example data. You would have to, if you're going to use a Mathematica ecosystem, which is easy, you would have to go to Mathematica data repository. Okay. There. So for your final project, if you're gonna be really impress me, okay, you might go to paper with code and use a technique that was invented in January 2024. Okay, I will be super impressed. You'll be guaranteed A+ maybe. Okay, but just to get a garden variety A, okay, you could get an A just looking through the data depository. It's a lot of them, and then go to neural net repository. Okay, so between applying this, applying this onto this and creating manipulate front end, so you can manipulate your data problem and configuration, it'd be a perfect project already. Okay, does that make sense? I think one of you was asking about the data. So yeah, I don't want you to turn in your example data thing for the for the final term project. I don't want that. Okay, so this is like that built-in flag classifier. It's just a gimmicky show feature, right? But it's used for teaching. It's used for teaching. It's used for playing, and that's why I use it a lot. Okay, so let's take a 5-minute, 10-minute break. We'll come back. Then I'll be more methodical, right? Take you through. Okay.